Chemical-grade alumina factory's construction project in Tayan Hilir, Sanggau District, West Kalimantan Province, was done by a consortium of PT Wijaya Karya, Tsukishima Kikai Corporate Limited, and PT Nusantara Energi Abadi. Chemical-grade alumina plant, owned by PT Indonesia Chemical Alumina, is a consortium company between PT Antam and Showa Denko of Japan. Chemical-grade alumina is a factory that processes bauxite into alumina. This is the first project in Indonesia using bauxite mining in West Kalimantan, which has a lot of reserves. There are two main processes in chemical-grade alumina plate: bare process and processing process. Bare process consists of liquor clarification process and hydrate production process. Processing process consists of calcination process and hydrate processing process. At the beginning, bauxite is transported periodically through belt conveyor and put in 3 bauxite storage tanks with a capacity of 300 cubic meters each. Tank capacity is equivalent to 8 hours reserves of the washed bauxite for avoiding midnight feeding. From the storage tank, bauxites are measured by weight scale at variable speed belt conveyor and then sent to road mill to go through the process of crushing, grinding, and reducing size. Solid slurry is inserted into 3 digester tanks equipped with agitator alternately. Solid slurry that is mixed with NaOH will react with the very high temperature conditions by chemical reaction. Solid slurry will go to sand catcher to be separated by particle size. Particles sized of 1 to 5 mm will be separated by inclined spiral classifier, then will be sent to mud slurry tank as waste, while the other light fractions will be sent using the pump to the thickener, which operated parallelly. Results of pressure plate filter will be transferred to the filtrate tank. If the size is less than 15 ppm, it will be transferred to the vacuum flash tank for temperature control, which setting process will be done with condensing steam emission. Hydrate is morphologically agglomerated particles which are consolidated by several primary hydrate crystals. Precipitation of hydrate particles shall be carried out using cooled pregnant liquor seeded with fine hydrate. This process distributes the shape and size of the particles as well as the purity of the particles. The hydrate production process consists of 4 precipitation streams in corresponding requirements for a great variety of chemical market at the 4 precipitation streams, namely Chain 1, Chain 2, Chain 3, and Chain 4. The Chain 1 is main hydrate production line in Tayan refinery to produce approximately 410,000 dry metric tons per year on a hydrate basis. The Chain 1 composed of precipitation, classifying, filtration, and liquor slurry stock stages. Slurry that is discharged from precipitation sustainably pumped using 2 hydrocyclones and 3 thickeners. The first cyclone flow will be supplied to the relay tank and then pumped to the product slurry stock tank. Slurry product from liquid tank transferred into the vacuum pan filters continuously after rough particles are separated by vibration sieve. Mother liquor will be distributed to the filtrate tank for washing process. Material products will be sent to the warehouse by truck or conveyor belt to be processed by the calcination process. The second chain consists of continuous precipitation and hydrate classification to produce 85-micron-sized particles. Pregnant liquors are put into precipitator by agitator. At the time of the target density is reached, slurry will be pumped to the slurry product stock tanks. Slurry product from the stock tank is pumped to the filtrate tank for filtration process. Then the product will be taken to the bulk product storage yard using conveyor. Chain 3 produces two delicate hydrate products that are 1 micron and 0.7 micron sized particles. Chain 3 begins with pregnant liquor put into a stock tank. From stock tank, materials will be brought to the gel precipitator equipped with a mixer. The slurry output from the slurry stock tank delivered to slurry hydrate tank through vibration sieve to separate particles. Slurry with a temperature of 55 degrees Celsius will be sent out from the slurry hydrate tank to the vacuum belt filters. Calcination process. At this stage, hydrate or gypsite changes to alpha alumina through dehydration and a lot of transition alumina. The calcination process shall be provided to produce 11 grades of calcined alumina products of approximately 134,000 metric tons per year on an alumina basis using the wet cake produced in the chain 1 and chain 2. Wet hydrate resulted in chain 1 are sent to the rotary kilns using belt conveyor, as well as the hydrate from bulk product storage yard. Wet hydrate, which already in the rotary kiln, will be dried in the drying zone without refractory lining with a gas temperature of 300 to 500 degrees Celsius. Solid product, excess from heat exchangers, will be transferred to the air slider to get maximum results. Some products that requires the addition of solid aluminum fluoride as a mineral or a hydrate collide acid also processed in a rotary kiln. 11 types of rotary kiln products stored in 2 silos with a capacity of 300 cubic meters and 4 silos with a capacity of 600 cubic meters. Hydrate processing process. At this stage, hydrate processed at various facilities, including the drying, grinding, and classification process. Hydrate surface treatment HD1. Hydrate washing. Hydrate surface treatment 2 HD2. Hydrate blending and sieving HB2. Hydrate blending and sieving HB1. Hydrate grinding and classification 3 HG3. Hydrate grinding and classification section 1 HG1. Hydrate grinding and classification 2 HG2. Hydrate grinding and classification 4 HG4. Alumina processing process. Alumina processed in section AG1 to AG4 to produce a variety of alumina products as needed. Processes that occur in each section are the grinding, and classification process. Alumina grinding section AG1. The purpose of alumina grinding and classification process section 1 AG1 is to produce fine alumina particles. Alumina raw material drawn from the container bag. The results from the rotary kiln is charged from container bags with electric hoist. Alumina grinding and classification section AG2. The purpose of alumina grinding and classification process in section 2 is to produce fine alumina particles. Alumina blending and sieving. The purpose of alumina blending and sieving process 1 is to produce blending alumina as a batch operation. Alumina repacking. The purpose of alumina repacking is to weight the raw material for grinding and classification process in AG section 3. Alumina grinding and classification section AG3. The purpose of alumina grinding and classification process in section AG3 is producing fine alumina particles as a batch operation using grinding and separating machines. Alumina surface annealing. The purpose of alumina surface annealing process is to heat treat AG3 alumina in an electric furnace. Alumina surface treatment. The purpose of the alumina surface treatment is to produce surface treatment alumina.